Hi guys, we are going to start fluid dynamics now. We have already done fluid statics. There we discussed fluids which are not in motion. This is fluid dynamics. Here we discuss fluids which are in motion. So what we are going to do is under mechanics, fluid dynamics. Dynamics is fluids which are in motion. So the first subtopic is I hope you have the note with you. So when I ask you to read the note, read the paragraph, then you have to read the paragraph, then only you get the maximum out of this. So we have a subtopic called fluid flow due to a pressure difference. In this section, we do only fluid flowing due to a pressure difference. There are other reasons. Which can cause a fluid flow. For example, we can take thermal convection. If you don't know about thermal convection, let's take a vessel of water like this, and if we supply heat, initially these bottom water particles, they will absorb heat and their densities will decrease. And these low density particles, they will go up, they will rise, and higher density cold particles, they will come down. So here we can see there is a circulation of fluids, or there is a circulation of liquid particles, a flow of liquid. These types of liquids, this flow is not caused by a pressure difference. It has caused by a thermal effect, some kind of a thermal effect. These kinds of flows we are not going to discuss under this section. We only do fluid flowing due to a pressure difference. There should be a pressure difference which is causing the fluid to flow. So what is a fluid? When we take the word fluid and liquid, what is the difference? Some of you are thinking they both are same, there is no difference. Okay, tell me an example for a liquid. The first example that comes to our mind is water. Okay, water is a liquid. So what is an example for a fluid? For a fluid also we can take water, right? We know water is a fluid. So what is the difference? Fluid is actually liquid, or gases also comes under fluids. They also comes under fluids. So air, oxygen, nitrogen, all these things we can call as fluids. So fluids are liquids and gases. Liquids are just liquids only. After that, when you are thinking about the nature of fluid flow, we can divide a flow into two main categories called a streamline flow and a turbulent flow. We can divide a flow into two categories, streamline or a turbulent. First category is streamline flow, or the other one is turbulent flow. So what is the difference between these two kinds of flows? Streamline is an orderly flow. It is a smooth orderly flow. So we can say streamline is orderly and smooth. it is a smooth flow. For a smooth flow to occur, should there be a high pressure difference or a low pressure difference? Due to high pressure difference, the flow can be a kind of chaotic, right? It won't be smooth. So for a smooth flow, there should be it should be a low pressure difference flow. So another characteristic is low pressure difference and low pressure, and also we can take low pressure and low velocity. Velocity of fluid particles are also small or low. In the other hand, turbulent, it is the opposite of streamline flow. It is not an orderly flow. It is not smooth. It happens under a high pressure difference, and velocities of fluid particles are also very high. So if we talk more about streamline flows, in a streamline flow, when you consider a streamline flow, the path a fluid particle takes, if we take a fluid particle here, let's consider that this fluid particle travels along this path in its flow. If we draw a tangent to this point, this tangent gives the velocity of that fluid particle at this position. So if we draw a tangent somewhere here, let me draw it like this, somewhere here, it gives the velocity of that fluid particle at this position, at this point. So it doesn't necessarily have to be same velocities, it can be different velocities. So this is v1 and this is v2, and directions are also different. So this is called a streamline. So what is a streamline? The path followed by a particle in a streamline flow. When we take a flow, there is not only one particle. There are hundreds, thousands or millions of particles. So we can take many streamlines when we consider a flow like this. So this is the direction of the fluid flow. This we called a streamline. This is a collection of streamlines. This we call a tube of flow. These are terms that we used to discuss theories in this section. So a tube of flow is actually, it is a confined region or confined set of streamlines. This is just like a tube, a fluid flowing inside a tube. Okay, you have space to draw the diagram. Don't write these things, just draw the streamline and name it the tube of flow, and name it just above the topic turbulent flow. So when you are drawing, I'm not going to give you time in the video. You can pause the video and draw, then you can play it afterwards. Okay. So in a streamline flow, we can consider, if not particles, fluid moves in layers. We can consider it flowing in layers. For example, let's consider there is a flow like this. Okay, fluid is flowing like this, and we can consider the fluid flowing as layers. That means we can we can say this layer, the velocity is to that side. The below one, the below layer, velocity is to that side. Likewise, these velocities it may be different velocities or the same velocity. We can consider them as layers, liquids flowing as layers. So by that definition, we call streamlines flows as laminar flows also. Lamina is a layer, right? A kind of a plate. For a plate also we call a lamina. In statics and in those Newton's laws, we dealt with laminas, plates. When you apply a force to a plate, how the forces are acting on it. Likewise, okay. What is that word? Lamina. Lamina. So this is a laminar flow. We can call this as a laminar flow too. Then we have turbulent flow. I told you that turbulent is the opposite of streamline flow. That means this is not an orderly flow, not smooth. So this is kind of a chaotic flow. This is a chaotic flow, and not smooth. This is and also irregular. The flow is irregular. If the flow is chaotic, it should not be flowing under a low pressure difference, right? The pressure difference should be high. That means the pressure difference is high, and also due to that, velocity is also high. So this is flowing at a high pressure, and they have high velocities as well. Turbulent flow. If we draw a turbulent flow, we can't actually draw the turbulent flow. Why? Because there are no set paths for the fluid particles. For a streamline flow, we can draw like this, the streamline. We can draw like this. But turbulent flows, there are no set paths. So if I'm going to draw, indicate a turbulent flow, illustrate a turbulent flow, I can just I may have to draw it like this. This is very irregular. This is very irregular, like this. You can draw this diagram in. You can draw this diagram at right hand side top before the topic steady flow. This diagram only. Okay, these are not streamlines. If it is a streamline, then we should be able to indicate that flow like this. And another characteristic about streamlines is streamlines never intersect with each other. So these are not intersecting. They can flow close to one another like this at some places, or there can be a larger difference between the two streamlines. They can be closer to one another like this, but they can't intersect with each other. They can't intersect like this. Let's discuss why they can't intersect like this. So if we draw a tangent, this gives the velocity of the fluid particle at that place, at that position. So if we draw a tangent here, it gives the velocity of this fluid particle at this position. Velocities can be different, v1 and v2. From that definition, if I consider this streamline and if I draw a tangent to here, I get the velocity of this particle, the particle at this point, as this, right? The same particle is also on this streamline. So if I draw a tangent to this streamline, I get the direction of velocity as this. Can there be two velocities for one fluid particle? No, there cannot be two velocities for one fluid particle. Therefore, streamlines, they don't intersect with each other. That is a very important point. Most of most of the students know that they are not intersecting, but they don't know the reason. This is the reason why there cannot be two velocities, two directions, two magnitudes for one fluid particle. Therefore, streamlines cannot intersect.